This is a second video on section 7.4, double integrals using polar coordinates. And so here we're going to look at example 214. Our region is a set of pairs xy such that x squared plus y squared is less than or equal to 4. So that's just simply the region bounded by the circle centered at 0, 0 of radius 2. And then we're going to integrate our function x squared plus y squared plus x over that region. And so recognizing this as a circle centered at 0, 0 of radius 2 helps us set this up as a polar integral fairly easily. We just integrate r goes from 0 to 2, theta goes from 0 to 2 pi. And so then we substitute, we basically write this in terms of polar coordinates. So x squared plus y squared is r squared. X is r cosine of theta. So we just have our function r squared plus r cosine of theta. Then we multiply by r because that's what theorem 212 tells us to do. So we have our r dr d theta. And so now we have set this up. This integral here is not terribly difficult to evaluate. Distribute the r through. So we have r cubed plus r squared cosine theta dr d theta. So we find an antiderivative with respect to r. The r limits of integration are 0 to 2. Substitute 2, substitute 0, subtract. And it simplifies to this. So we have the integral from 0 to 2 pi of 4 plus 8/3 cosine theta. This is a calculus 1 problem. Find an antiderivative with respect to theta. Substitute 2 pi, substitute 0, and subtract.